Hello, everyone, and welcome to another episode of XAML TV. Today, I am joined by Samuel Englard. He'll be talking about 3D does not equal disagreeable and distressing and Dour. In other words, he'll be talking about 3D and XAML. How you doing, Sam?
I'm good. You, Brian?
Doing pretty good. So that's a pretty interesting title you came up with.
Yeah, I got a bit geeky on it. I was trying to think, what title would I go for 3D stuff? And, I could have done the boring 3D XAML, but it just seems sort of, I don't know, boring.
Yeah, no, I like it. It keeps things interesting. So what part of the country you're from?
Good old Northeast, New Jersey. I'm about 15 minutes, actually, from Infragistics headquarters. I've been there a couple of times. Lovely building.
Okay, so do you attend the user group there?
Yes.
Awesome. Great. So let's go ahead and let's get started. You can show us all about 3D.
Alrighty. 3D in XAML is really nice because, I've done it actually with DirectX, and doing in DirectX will drive you nuts. You have to actually understand vectors and layout and all that crazy stuff. Now, admittedly in XAML you do need to understand it to some degree, but it's abstracted for you for the most part, so you're not going to the nitty-gritties. Now, you can do some basic boring stuff with it, like, let's see if this thing will run for me, hopefully. Here we are. A nice little 3D scene. All created in XAML. But, bit boring. But, more practical uses, you can actually even, besides having 3D scenes, where you can draw graphs or just random boring objects, I suppose, you can even actually put controls on these screens, and they will actually work. Okay, I've got a button here. This button is... Now, yes, you can do this in Silverlight. You can do this weird 3D perspective things, but this is WPF. The button's here, and it works still. So, just because I made my button in the 3D world controls does not mean I've lost the ability to interact with my controls, make them do things for me. So you can actually build an entire UI within the 3D world, and you want to switch windows. You could actually maybe, I don't know, do a box rotation kind of thing or something.
So is that using like a transform, or is this something completely different?
This isn't a transform. This isn't like the XAML in Silverlight where it's a transform and you're just saying perspective, make it look like it's rotating here. Here you're working actually within the 3D world. One of the things I'll actually show is how to build this little hello button here. So it's a very useful. Admittedly, in some practical sense, what I'm doing here is a bit useless. I've tried to make use of a 3D user interface. It's more of a gimmick than anything else in that regard. The big use cases for it would be if you're making, let's say, some kind of grid or something, a graph for, let's say, a financial application. You want to show the graph in 3D. Well, instead of having to break into DirectX to do that, you can stay completely within XAML. And let's say you wanted to make it that the user can select one of the 3D objects to get a zoomed in of it or something. Well, it's clickable. Everything within the 3D world can be clickable. You can make it. You can put buttons there, and all your layout objects you're used to working with in XAML, you can actually put right in there. So you can make it. You can put on the bar. You could put a picture or even a video. In fact, you can do 3D videos and such. The other use for it is 3D games. If you wanted, it's a bit hard to do. I've tried it. The downside to making 3D games with it is that 3D games, people want it to look so crazily realistic. And really good realistic is really hard to do. And at that point, if you're going to spend that much time on your graphics, you may want to either drop into DirectX or get a 3D tool. That actually, there are a couple. There's one called XAML 3D. They spell it with a Z, Z-A-M 3D, which actually is a 3D editor tool, but instead of outputting some object file or something, it actually creates XAML for you. I used to have the program. Unfortunately, my license expired and I haven't gotten around to renewing it, so I can't show it off. So that's some things you can do. So let's get started on the 3D world. Okay, so obviously you can't just put 3D wherever you want. You have to actually declare where you're going to put it. You have what you're doing when you're working with 3D in XAML is there's a 3D world, and you define a window into it. And then within this window, you can control this window. You define cameras, light, etc. It is working within a 3D world. So your basic 3D object you actually work with is, let's see, it's the viewport 3D. And from here, you actually are creating a viewport into this 3D world and such, so that you actually can get things that you view into it. Now, the problem is with the default thing is there's nothing really there yet. We've got our viewport, which defines where you can say it. It doesn't have to fill up the whole area. You can put things over it, which is another advantage over DirectX. For those of you who have ever done trying to merge Windows Forms, WPF, and DirectX, you can run into problems when you try to put something from one type over the airspace of another. XAML 3D content, you can put 2D normal content right over it if you wanted. So, first thing we have to do is give ourselves a camera. I'm just going to copy and paste one. I don't feel like typing this manually. Pretty much, you position it within the 3D world using the 3D coordinates X, Y, and Z. What direction it's looking. In this case, we're looking towards the back, or negative Z. And our field of view is 45 degrees. So the camera has a view of 45 degrees. That's pretty general and common.
So in 3D land, X would be our horizontal, Y would be the vertical, and Z would be the depth?
Yes. Z, off the top of my head, I actually should... I don't know this. I thought I remembered reading this right before to make sure I remember it, and now I don't remember it. Z goes forward and back, I believe. We'll find out if I'm wrong on that one when we mess with things. But positive Z is towards you, and negative Z is away from you within the 3D world. Okay,
now is a camera required? Do you have to declare a camera?
Yes, you have to, because the problem is with that, you need at least one camera. The problem being, if you don't have a camera, what you end up with is, there's a 3D world, but you can't see it.
Okay.
There's two kind of cameras. There's perspective, which is the kind we're using here, and the other kind, which if I just go here, I'll get the name for us, is the orthographic. The difference between the two is how you actually view the 3D world. The perspective one will make things, when you're viewing it, if it's farther away, it will actually look smaller. If you have the other kind, an object will look the same size no matter where they are relative to each other according to the z-index. It's almost like making the z-index becomes more like it is in a web browser, where it just decides what lays on top of each other instead of actually being a 3D where you actually have things are farther away from you. Alright, so the next thing we have to do is actually have children in here of the view space, just like a grid has your children. Now, your children for your viewport is actually your world. In your world, you will have two kinds of things. You will have the lights, and you will have actual objects. The light is actually how you can see, because otherwise your world is dark and you can't see anything. The 3D world models the real world very closely. So, let's get our children up. So the first thing we do is create a light. The way you have to do it, though, is a light itself cannot exist on its own. Don't know why, admittedly. It's a very weird concept from other 3D worlds I've worked in. But there you go. So you have to make it part of these model visual 3Ds. These are the objects you actually work with. They are what the children of the viewport must be. They're sort of just like simply a single content container, but that exists within the 3D world. One of the types of content you can give it is a light. There's directional. You have a directional light. You have, let's see, what do we have? We have an ambient light, directional light, a point light, and a spotlight. For the most part, they're pretty self-explanatory. Ambient light means it just gives off the light in all directions. It just exists light. A directional light is sort of like having a flashlight. You point it in one direction, but it spreads out going from there. Your point light is more like a laser pointer. It's a very small... It's a beam that's concentrated. It does not spread out, although it can be very large. A spotlight is same idea, except it's even a larger area that you can go with. So, in this case, we'll use directional light. It's the most common. The reason is it works sort of like the sun, of where the sun's in one corner, and it gives out light. You'll get shadows from it when the objects are out of the light a bit and are blocking it, and such. Alrighty. Now, unfortunately, building 3D objects, you sort of have to do manually. Simple ones you can do easily. More complex ones you're going to drive yourself nuts with.
Could you use a tool like Blend to help create these 3D objects?
Blend does do them. Admittedly, I actually don't have Blend on this system. Unfortunately, I had to reinstall recently. Blend will do 3D stuff. It will help you a bit, but the problem is in the end, Blend will only help so much. The big power Blend will give you, though, over Visual Studio, is that Visual Studio, unfortunately, if you want to work the 3D stuff, you've got to type it out in some form or another. While in Blend, you can't create the 3D objects using your normal stuff. You can drag it around once you've created it. But the big advantage they give is that there's a 3D format called Object. It actually ends in Object. Conflicts terribly with Visual Studio, but there you go. Which a lot of open source 3D libraries use. Blend will import that and convert it to XAML for you. I've actually used that ability before if I wanted to work with things. So unfortunately, you can't though create just raw shapes. In Blend there is no square, or I should say a cube you can pull off and pull into the 3D view for you. Unfortunately, if you created your cube, Blend will let you. In Blend, you can rotate it a lot easier. You don't have to manually type the rotations. But there is unfortunately no toolbox for the 3D world. Unfortunately, trust me, I'd be a very happy camper if there was. Some of the more advanced shapes, like in the first sample, you saw that I had the cylinder, the cone, and the sphere. Those are actually not outright typed XAML. Those are generated by code because calculating exactly where every point on those should be is very hard. I'll show the code that we use to do those, but that will be later on once we got a basic idea of how we do this. So, to build our Hello World button, next thing we're going to do is build a rectangle in the 3D world. This is a flat 3D surface that will have two sides to it, a back and a front. We'll put the button on that. Your more complex shapes are actually built of multiple of these. So, for instance, if you had a cube, it's actually 6 of these rectangles that you would position. Now you could do it there's a couple. You could build it as those 6 rectangles. You could make it as a merged shape. The difference between the two would be if you made actually 6 rectangles, you can control each one independently. If you made it one giant shape, you'd have to deal with it as one giant shape. A conventional way to think of it would be, let's say you wanted to make your 6 sides of your cube different colors. If you made it all one giant shape, you'd have to have some image that would have the colors laid out just right for you, and then you could put it onto and it would wrap around it nicely. If you made them actually different rectangles, you can do brushes like you're used to, because brushes work here just as well. Just like you have brushes for your 2D stuff, brushes work here in the 3D world, and you can just put a different color brush for each side, which will make it so much easier.
So creating it out of multiple shapes is more work, but it gives you more flexibility.
Exactly. The downside, though, is with more work for you also is more work for the computer. Because now instead of keeping track of one object that is slightly more complex, it's got to keep track of six individual objects. So it's a bit of a trade-off here. If you're creating one cube and that's all you're going to do, it's not going to do anything fancy like in our example, you could get away with probably making the 6 sides. You're doing that crazy graph where you're going to have 3,000 objects going around and you want it to go really fast, you're going to want to care a bit more about it. As one example I have actually for a client I once built was, it looks like a 3D cube to the end user where it's displaying pictures on a rotating. It randomly decides which way the cube will rotate and each side will show a new picture every time it rotates. Very nice animation. Problem is, keeping all of that in memory is terrible for performance. So after tweaking around a while, what I came up with was this. I have 2 rectangles in memory. One is visible to the user at a moment, and then I have another rectangle that's hidden. This rectangle is hidden in the position of the side of the cube that's going to rotate in next. So if we're rotating in the top, my hidden rectangle is on the top, joining angles. The 2 sides of the rectangles join at the top. Then when I rotate this quasi-cube, it looks like there's a cube that's rotating to the top, but really it's just 2 rectangles rotating nicely. Then when the rectangle that was on top is now in view, I have the rectangle on the bottom, and I'll move it to wherever I want to rotate next. So I'm constantly changing the position of these rectangles to make it look like I really have a cube. The performance gains, I don't remember the exact numbers, but it was worth it to me to actually drive myself nuts moving the rectangles around. So you can do these weird mixtures if you don't have every side visible at once. Alright, so let's start with actually building a rectangle. I'm just going to copy in the code for the rectangle, and then I'll explain it slowly. Okay, so now we see our hello button actually on our screen. So let's go through what we have here, what I pasted here. So we have the viewport 2D visual 3D. This is where we actually create the 3D objects. We have a mesh 3D, which is the actual data that the 3D rendering engine needs. It consists of 3 pieces of information. Positions, triangle coordinates, and texture coordinates. Positions are actual points in the 3D world where we're going to connect the lines to make our 3D shape. In the case of a rectangle, it's the 4 corners. The triangle indices say how are we actually, or is the fact that in the 3D world, while we're thinking a rectangle, for very complex reasons, 3D stuff thinks of triangles. The reason is because a triangle is the least sided shape you can think of, so almost everything is actually made of triangles. As such, our rectangle really consists of 2 triangles to the 3D renderer. So to tell it how these 4 points work, we connect them. And the way we connect them, we have the 4 points here, which are 3D coordinates. In the case of XAML, you just give a new line to each one, or you could, if you're crazy enough, actually do the XAML object, but you can shorthand it like this. What you can then we do is we say, I want to connect point 2 to point 1 to point 0 for one triangle, and then I want another triangle, which will be point 0 to point 3 to point 2. Now, the order you connect the points does matter, because that will control which side of your triangle is the front and which side of your triangle is the back. And this matters because when you color your triangle, putting whether it's a control or a color, a texture, even a video, you have a different one for the front and the back. And if you have your triangles are actually facing different directions, it can look a bit weird because you will have half your rectangle will be showing what you expect to be in the front and half will be showing what you expect to be in the back. So that can get a bit weird. So unfortunately, it's pretty much just trial and error to figure it out. After a while, you'll memorize it. The indices, what these are for is when you have more complex structures, when you have 3,000 points and you're connecting them in weird ways, or like a sphere or such. This controls how the rendering engine knows how to wrap stuff. In our simple rectangle, there's not much to it. We're just saying the corners exist. Alrighty. So that finishes up the 3D mesh. Then we have the material, which is the front. In this case, it's a diffusible material. We have different kinds of materials. You have diffuse, emissive, spectacular, and material. These pretty much deal with how they reflect light. Diffuse is the most basic. Light just deals with how you expect it. Spectacular means it reflects. Emissive means it gives off its own light. And material group means you can actually group them together and create a weird combo. In this case, I said its brush is white. That brush is the normal brushes we're used to from the 2D world. So it could be a gradient or anything crazy. I could bind it also, if I wanted. Is virtual host material. Visual host material, that means that this will be something we're going to put something we want to be able to touch. The transformations are actually how we rotated this object. In this case, I said the center is off of 18 pixels. If we see, I can make that 10 pixels. Now it's off screen a bit because we're rotating a bit off. If you think about your 2D transformations, when you rotate, default is the top right corner. Well, and maybe you want to rotate around the center, so you have to move it. Same thing in the 3D world. In this case, the 18 is sort of just mathematically calculated. The axis is what axis this rotation applies to. The X, the Y, or the Z. Now, you have to think about this for a sec because it can get a bit confusing. When I say rotate around the X-axis, I don't mean it goes from X-axis to X-axis. I mean you have to think about as though we have the X-axis is a bearing and we're rotating around it. So rotating on the X-axis, the first one, would mean that it's rotating so that if it rotates positive, it's rotating away from you. The top will go away from you. And if you're rotating negative, the top will come towards you. The Y, which is what we're rotating, is rotating around the Y-axis itself. So a positive rotation, which is what we're doing, would be to the right of you. Negative, to the left. The Z would be a bit weirder to explain, but sort of the same idea, just, well, easier to show, I suppose. Like that. It actually it tilts, kind of. Almost what we would call a 2D transformation. Now, you can actually combine these within one statement to get, now it's rotating 45 degrees in both. Now, I put ones, but if you put another number, it will now magnify. So now it's 90 degree, it now magnifies the rotation slightly over the y-axis, and the y is twice as rotated, so that it looks stretched a bit now. I'm just going to put it back to the way we had it before. Alright, now we have the actual visual. And it's just 2D content. This is the content actually of it. It's a single content holder though, so if you wanted to put more than one thing in here, you would have to actually put a grid or something, but it's a button. Now if we ran this example, the button does click. You can put handlers on it. So you can do some pretty nice things with it. It does get a bit complex doing this stuff, and you can drive yourself nuts at times, but it's as simple as that. There we go.
Well, it's definitely pretty interesting in making a button 3D, that's for sure. A lot goes into it, especially I think it takes a while to really understand how each of those axes and those numbers and those values affect the rendering of your element.
It does take a while. Unfortunately, I can't explain it simply. I mean, even I at times confuse myself. I've worked in 3D for a while. Before I was in software, I actually did multimedia presentations and such, and I worked in 3D stuff. So I have a vague idea of 3D concepts, although not from a XAML perspective. So these crazy concepts to me aren't completely foreign, but even to me at times it's like, how did I do that? Generally, you will find you can mess with the camera and the model to get things you want happening. So for instance, sometimes you'll want something to move in your 3D world. You can do it two different ways. You can make the model move or the camera move. Making the camera move has the advantage that if you have a bunch of objects, they don't all move. So like, let's say you want to pan over, like in the case of our 3D graph, I keep on going back to because it's the most practical example I can think of. One option is you could group. You can create groups of 3D objects. You could group all your 3D shapes and rotate that. Or you can move the camera around the object, actually. Almost like, the difference is almost if you have a block in front of you, rotating the object is rotating that block. Moving the camera is you walking around the block. There are practical differences between the two, though. The camera is a bit harder to work with, personally, I find. Especially because now you want to get back to where you were, it can be harder to remember and such. The downside to moving the model, though, is that it's a lot harder for the computer because it has to redraw the 3D world. Because the thing to remember is that with a camera, you are looking at the 3D world. It's just like in reality. I'm not looking behind me, but there's stuff behind me. And the world doesn't have to deal with that. The stuff is there. It's not being moved in any sense of the word. If I turn around, the stuff didn't change. Assuming we're ignoring atom theory. But if I move the stuff into my perspective, and I change where I'm looking, well, that stuff had to move now. It's easier for me, maybe, but it's harder on the world, quote unquote, because the world had to move it. The world in this case would be, I'm supposing, someone else or maybe you, but the idea works. So it's a trade-off of, is it easier for the computer or is it easier for me?
Now, is there any documentation out there that help people start learning about all these things you're talking about and all these values and what they do and best practices maybe?
Best practices, I've never really found a good article, at least for XAML. A lot of them are just general 3D concepts. As far as 3D, there is one good MSDN article I will send you that you can put in the links. Its URL is crazy long. I'm definitely not going to say it. It's from one of the MSDN things. It's actually from before even WPF was officially WPF. It's from its Avalon days. But it's a very good article, and it's really useful, I've found, generally speaking. The only thing I want to show you guys the code that actually made those 3D shapes. It gets a bit crazy, but it is sort of a nice idea to get an idea, at least, of how you would do those, I think.
Oh, no, that'd be great to see those.
Yeah. So I'm going to just pull down my Visual Studio instance that contains that project. Alrighty, so the 3D project is this one, actually. Now, to do those, they share a lot of code, so it's a bit of common code. But building a 3D object, unfortunately, gets a bit complex if you want to actually make it code. It's a lot of crazy inheritance here. I mean, this is a base class I had that has to be created. You have to deal with material changing. Deg to rad is simply degrees to radians because we think in degrees. Well, 3D world thinks maybe in radians in some cases and such. In simply, this is just a base 3D object that's containing common code. Just keeps track of the material you want to overlay over your 3D object. Make sure that we keep track of changes to the materials, and defines methods that we know we'll need to call. Tessellate being the method that actually generates all those points. So let's do this sphere. It's one of the easier ones to understand. Alrighty? So tessellate. And what it actually does is, it's the math to figure out all those different points. It's a bit crazy, but it's almost calculus, actually. But it goes through all these points and says, oh, okay, I am at this radius, I'm going to start at this angle, and I'm going to go through a for loop, calculating all my points, and I'm going to get the position, get the normals for it, get the texture coordinates for them, add them to this mesh, and then return this mesh. And it's very crazy math. I'm not going to go through the math, it's geometry. But that's actually how they're created, because let's look at this. This is what? 86 lines of code. If we add to it the primitive that came before it, we made under 200 lines of code. To create this actually in hard-coded values would be immense. I don't even want to think about how large it would be. The other disadvantage to doing such a way would be, I don't think either of these do it, but with these you can actually scale it. Because just like your 2D object, you can set, one of the nice things you can do with 3D objects, besides rotating them, you can also scale them. The advantage of this is, let's say you make your rectangle 1 by 1. You can scale, using scales, make it now, alright, I'm going to make it twice as wide as it originally was. Now, the advantage of that is that the computer, you don't have to now calculate manually, okay, how far apart should this be? The disadvantage is that when you're working with, like, a sphere, well, a sphere in 3D terms, obviously, like in all our computer drawing in 2D world, there is no such thing as a real curved surface. So we have, in the 3D world, we have a bunch of those triangles we discussed before. The goal is to have so many of them that the human eye won't see that there's really just a bunch of flat surfaces making this up. The problem is when you scale it, those triangles also get bigger. The computer doesn't make them smaller, which means if you scale it big enough, at one point the user will see, oh wait, that's really triangles. When you're doing it mathematically, you can actually calculate, oh wait, I'm going to need more triangles. So there's something to be said for doing it this way. A cylinder is is a bit easier for you to think about. It's really just doing a circle over and over and over and connecting all those points.
So basically, all of these shapes are made up of little triangles.
Yes. That's actually how the 3D world works. Your video games you play, it's all those crazy little triangles. The reason we use triangles is because it's the smallest actual shape we can make. You can't make anything less, and the problem is and it creates so many options. Because let's say we use something like a square. Well, you can use a square, but if you make a sphere using squares, it's going to be blockier than one using triangles, because you have less edges. There's less surface area to it. It will look smoother to the naked eye. It's like, in essence, it's the equivalent to, it's the basic idea of why when you want to draw a circle, you're going to use a dot instead of individual lines. Same idea, but in 3D world. Unfortunately, we can't get away with such small concepts because, well, a line is not 3D anymore. So, you can do some pretty cool things with it. Unfortunately, the cube thing, I wanted to show it off that I discussed earlier, but unfortunately, it's in changes, and the version I have locally does not run, because it's currently going through some debugging changes, so it will not run for us. So you can do some pretty cool things with it. And one more thing to remember, though, is that not only can these things are XAML, which means everything you're used to doing with XAML works here. Which means you can bind, you can template, you can do styles, you can do triggers, and you can do animations. So you can get something crazy like this, where now you can actually see it's a 3D world because they're rotating.
That's pretty slick.
And this is XAML. One of the nice things about this over DirectX is, yes, you still have to maybe do a bit of the 3D concepts where you have to understand what the points are and such, but you get the power of XAML at your disposal, of that you can bind things, you can create the images the normal way, and you're working in a managed world, which is much nicer than C++. I know C++ and hate when I go there.
Now, creating your shapes in code, does that affect or add any complexities when you're trying to apply styles and stuff through XAML or through resources?
Not really. It's no different than you creating a code control. In the end, this is XAML 3D is XAML 2D almost. It's the same as if I spent the time to create a control in 2D. Like if you went to, infodristics, you guys make controls. Those controls, I'm willing to bet, are a lot of stuff is hard-coded there. It's not a XAML file necessarily. If you did that, it's the same idea. It's whatever you do with one, you can do with the other. Obviously, it may come down to you because you have to make sure your code doesn't do something that breaks it. So you may want to be careful with dealing with dependencies and such, which can get it, dependency properties, that is, which can get a bit hairy in code when you're doing it manually in code. I mean, the example being here in the primitive, I mean, this is a dependency property. It's a bit weird, complex, and even I can't explain it quickly. It's weird. But you need these to be able to set properties and such. So if you're going to create it in code, you need to think about, if I'm going to create a property of my custom object, do I want it to be settable? If I don't want it to be settable, well, then it's not a big deal. Unfortunately, this stuff is not carried over to Metro.
Oh, so as it stands, the Windows Store apps don't have 3D capabilities?
No, well, it's not you can. It's officially, okay. Well, unfortunately, when we went down to Silverlight, we lost the 3D, and it was one of the big things I hated when I went to when I started doing Silverlight development. I didn't have my 3D stuff because there are times when I would use this for just little sparkly little things. It looks so nice. Then in Silverlight, we gained the ability to have perspective, which was quasi 3D, which actually I have to admit, from a general standpoint, is probably more productive than this 3D because it's a lot easier to do. Hands down, it's easier to do perspective. When we went to Metro, unfortunately, as I know they did not carry over the 3D from this. Off the top of my head, I don't remember if they dropped the perspective from Silverlight or not. Unfortunately, their official answer, if you want to do 3D, is their same answer to why they dropped X and A. Go to DirectX. Drop down to C++. Do DirectX. My best guess as to why is because, admittedly, I don't think many people are doing this. Because the problem is, I admit, this is hard. You have to understand these crazy 3D concepts, and you have to think in them. And it is a lot of code to type. Even if you make them XAML controls or code that you can repeatedly use over and over, it is a lot of code. So there's not too many instances of using this in production. I mean, I don't even think Infragistics has any 3D code. At least XAML 3 is WPF 3D anywhere.
Yeah, we did have a blog post. We have a blog post in our blogs that show how to implement 3D into our XAML graphs. So that might be worth a look at.
So that I don't know, but that's one case. But the keys, well, there you go. Proof that the graphs are about the only use case of it. But the problem is, for the general population, that's not needed. And the idea, I'm assuming, is that most people who are using all the 3D stuff is games. I have to admit it fully. The biggest use for it is games. And if you're building a game, more likely than not, you know C++. So Microsoft's decision was, whether for right or wrong, to just drop it. I disagree, but then again, Windows 8 commercials aren't. It's my development. That was Windows 7, not Windows 8. Just saying.
Well, Sam, I really appreciate you taking the time to show us all this great stuff about 3D and XAML. And I know I've learned a lot. I'm sure a lot of our viewers have learned quite a bit. You send me the links to any documentation or anything that you recommend. I'll make sure they're along with the post. Any sample code, I'll make sure it's posted. And I really appreciate you coming on the show.
Happy to be here, and I'll definitely get the MSDN article. I can link to the MSDN library articles on this. I don't think I know any good 3D. Well, actually, if you can link to the blog post on the Infragistics 3D graphs, that may be interesting.
I think I can work something out on that one.
But I'll definitely get some good links to you on that.
Thanks a lot. Thanks again, and we'll see you next time.
Thank you.